So we're thinking about our learning targets 3 and 4, our explain 1 activity, kind of pulling together all the big ideas, starting with your first topic you had here, greenhouse gases. So this should be a term that you've heard before, and maybe we're reintroduced to a couple ideas of what greenhouse gases are. Hopefully coming to mind are CO2 or carbon dioxide, methane is another one, and also H2O, or of course water vapor. All of those are considered to be greenhouse gases because they have a job to do in the atmosphere, and that job is to help regulate the temperature of the atmosphere by keeping heat in. That's what these three gases do, and so that differentiates them from other gases in the atmosphere like nitrogen or sulfur dioxide. So these gases keep heat in, and so we're wondering, well, what does that mean to us? Is that a good thing or a bad thing to have greenhouse gases? Well, on one hand, it's a good thing because without them, our temperatures are hundreds of degrees below zero. We have no atmosphere, we have no climate, we have no regulator. So we need greenhouse gases. But on the other hand, we do see some negative instances happen with that relationship between greenhouse gases and temperature. When we see a big change in one, we see then a big change in the other. So an increase in any of these greenhouse gases brings a large temperature increase with it. A decrease in greenhouse gases brings a decrease in temperature. So any imbalance that we see does have an impact. So thinking big picture, this is the statement we wanted to know. So if you're taking notes, making a few things down on your explain 1 or in your learning targets, this would be the comment to have. It's the greenhouse effect keeps heat in. These gases, like carbon dioxide, keep heat in. That energy that hits the Earth's surface doesn't all get absorbed, right? Albedo, we know some is reflected. And then these greenhouse gases spread that heat out into the atmosphere in all directions. So we appreciate that. But like we said, any imbalance to the amount of greenhouse gases then creates that same balance, or imbalance rather, in temperatures. So if you're taking notes and you want to pause, go ahead and do so. Otherwise, we're moving on to our next topic of Explain 1, which was volcanoes. So thinking about what impact volcanoes have on climate, we should be able to indicate if it's a warming or a cooling, and how do we know what's going on. The way we got this information in our reading was looking at this graph. We had 4 vertical lines showing volcanic eruptions over time. This red line was looking at change in global temperature. So what we were focusing on is what happens to that line after each volcano. So when that line crosses the time frame of the volcanic eruption, what happens to that temperature? And so we're noticing a trend that each one of these temperature arrows is essentially dropping as the volcano erupts. And the reason that's happening is because what's being erupted from the volcano, this cloud coming from the volcano, is of course mostly ash. But what we're focused on are these little particles. The sulfur dioxide, these little particles act the opposite of our greenhouse gases. They reflect the solar energy back to the surface, not allowing it to get down here to whatever surface they're below. So again, if you're taking notes, making some this is a good spot to pause and write in this note. The big idea here is that the sulfur dioxide from the eruption blocks out that solar radiation, causing it to get back to outer space and not be absorbed by the surface. So we see these short-term drops in global temperature. For about 3 to 5 years, we see the temperature drop slightly due to the fact that now sulfur dioxide is bouncing around the atmosphere, reflecting rather than absorbing solar energy. So it's kind of like the opposite of our greenhouse gas. And this is really going to help you out with the learning target about volcanoes. I think it's number 3. And the last idea we're thinking about is human impact. This is learning target number 4, kind of combined with that idea of the greenhouse gases. We know that humans do things on Earth that can also impact global climate. A lot of these we've looked at are natural factors. There's nothing we do to control tilt or albedo or volcanic activity, and we can't control those things. But this human impact is one thing we can control. So the question is, what are we doing and how is that impacting climate? Well, we can see here that the amount of CO2 over time has changed normally on its own, right? We look at this line for the last 800,000 years, and we do see fluctuations naturally happening. But when we think about the time frame humans have lived, which is essentially this part on the graph, we see a big increase to the amounts of CO2 that are in the atmosphere today. And that increase is due to humans. Human use of fossil fuels, things like gas, oil, coal. These fossil fuels are used for energy production. So by doing things that use energy, by driving a car, by using anything electronic, including lights, eating certain foods, purchasing certain products, all of those have used fossil fuels either directly, right? You're using the fossil fuel here when you're driving the car or turning the light on, but also indirectly. Different products and materials need energy to get them to be able to be eatable. That's not the word. Edible or purchasable in the store. So energy is used either directly by humans or indirectly with the things that we purchase, and that use of energy puts CO2 in the atmosphere. So the temperature impact, just like we saw here, is the more CO2 in the air, the higher the Earth's temperature will be. So if we could predict what's going to happen with this temperature on the graph, we would predict an increase moving forward in time. And so again, this idea here is our learning target 4. So what we recommend is you pull up your learning target sentence starters and have those side by side with you as you work your answers for those 2 learning targets.